How about we replace that EA with a different letter? Yeah.
If you're living with zero, then the quadratic formula is the matter. Is it one? Can you answer my question?
Okay. Well, good afternoon. Excellent way to start the class period. I really appreciate your hard work and effort, but I would like you to feel a measure of success along with that effort. So I tried to extend the time because there was quite a few people who, after a while, finally realized some things. I didn't quite see anyone who realized the first key to the problem. So I am going to halt here so that I can give a little bit of guidance, and then I am going to have you work it out. And I am going to reveal the answer. So did anyone feel as though they arrived at the correct answer to the problem? Come on. It is not, but again, I appreciate your effort. 5, okay. The correct answer is 5. So it doesn't matter what the answer is, and I've been talking to you about that idea for a very long time. So Dianara, I'm going to explore how you did it in a few minutes. I want to get them started on my perspective. I'm thinking that you did it the same way I did, or at least a small variation on it, because we haven't been able, we being your peers and I, have not been able to find another path that works. So as far as I can tell, there's one path to success. And it starts with understanding this right here, and the fact that you need to not be a robot and you need to think. So let me get rid of some of this as I did earlier as a hint, and let's work through what we can. So we're going to get rid of this, and we're going to get rid of this just temporarily to help us focus on what is important to start. What theorem immediately jumps out? Which theorem immediately jumps out? Caleb?
Segments of sequence.
Very good. And that theorem says that the square of the tangent is going to equal the product of the external segment and the entire secant. So let's go ahead and set that up. But there's something missing. The square of this segment will equal the product of this and the product of the whole thing. So what's missing? That's required. Sharik? Yeah. So it's missing. I even saw someone on their paper write a question mark. But do we use question marks in Algebra 1 honors, Geometry honors, and beyond? What do we use instead of question marks? Nathaniel, what do we use? You use variables. So can someone pick a variable for this length? Alexander? Q. Good. We'll use a Y. Thank you. You trying to make me write a little... You got to pick the fanciest letter? Okay, I'm just joking. So, but let's keep it simple. So we've got Y. And so now let's set up the equation. So you go ahead. Set it up. I'm not going to do it for you. I'm just going to guide. Okay. Yep. So, Dianara, what do you get when you write out that equation? Just that first line that you wrote right there.
Y squared equals
Very good. That is the equation that represents the theorem and what we have here. So now let's go ahead and simplify this. And we end up with y squared equals, and now you got a FOIL. FOIL from last year. Go ahead, you do it. FOIL. So, what do we end up with? FOIL is supposed to be quick method. If you don't remember how to FOIL, I apologize. I'm not going to sit and spend time on that. Back to Dayanara. What did you get as a result of FOIL?
X squared plus 4x minus 5.
Outstanding. And that is what you get. So now we have an equation that represents that first part of the picture. But while you were working, I brought back the other part of the picture and I whited out the first part. There's a reason why. We have an equation that represents part of the picture, but we can't do anything with it. There's two variables. Can't solve an equation that has two variables. We can find ordered pairs that make it true, but we can't solve it. I'm asking you to find a particular x. So when you need to find two variables, what do you need? Another what? Well, we have the two variables. We have the x and the y. We have one equation. What do we need so that we can find both of them? Sheree? Another equation. We need another equation that has those same two variables. So now we have the other part of the picture. So what theorem jumps out when you look at this part of the picture, now that I've whited out the other part? What theorem jumps out at you? Nobody recognizes it? You can't even look at the picture and just pick it out? Thanks, Dole? Yeah, it's the same theorem, which says the square of this length will equal the product of this length and the entire secant. But now there's an issue. Do we know this whole distance, this tangent? This y represents all the way up to here. It doesn't represent the whole thing. So now, again, we're missing something. Anyone know what it is? Go ahead, come on. Yeah, the whole thing is 2y. You have these tick marks right here. There's another y right here, which makes this whole distance 2y. The square of that distance will equal the product of this distance and the whole secant. So the square of 2y will equal 2x times 2x plus 6. Excuse me. Sorry. That's the whole distance. Good. Now simplify that. You do it. Good. That's not right. That's not right. So what do we get as a result when we simplify everything on the left and everything on the right? What do we get as a result? Kayla?
4y squared equals 4x squared plus 2.
Very good. 4y squared equals 4x squared plus 12x. Very nice. So now we have our second equation. So close to the end, you don't even realize. So let me take a quick side trip over here to remind you of something very simple. What if I had two linear equations? Now I'm going to write on my whiteboard. What if I had y equals 2x minus 1 and y equals 4x plus 3? How can we solve that system? How can we solve that? Come on, you already know this. How do we solve that, Eric?
They're equal to each other.
Why?
Because both are equal to y.
Exactly. You could not have said that any better than he said it. Y is equal to this expression. Y is also equal to this expression, which means those two expressions must be equal to each other. So how can we apply that same idea here? I have y squared equals this expression. I don't have y squared equals that expression, but it seems awfully close to it, doesn't it? Ziamara, what can we do?
Multiply y squared plus the equation times 4.
What's that? Say it again.
Multiply the y squared equals x squared plus x4.
Very good. You can absolutely do that. So you can take this entire expression and plug it in for y squared right here and then multiply by 4. You can absolutely do that. There's a slightly easier method to use. It's almost the same amount of work. Eric?
Divide the bottom equation by 4.
Yeah, divide everything by 4 right here, which works out super nicely because of the numbers. That cancels, and that turns to a 3. So we actually end up with this equation. Y squared equals x squared plus 3x. And now the two equations are y squared equals x squared plus 4x minus 5, and y squared equals x squared plus 3x. Eric already told you what you need to do. Go ahead and finish it out. You already saw it? Very good. So, that certainly was not easy. That certainly took some ingenuity, some creativity, some knowledge of geometry and algebra. Required a lot. Most of all, it required some perseverance and some patience. Most of you were on your way to success. Unfortunately, I didn't have an hour to devote to one question, although we did devote quite a lot of time. Anyone have any comments or concerns?
I don't know what the way you did it was called. I think it was called elimination.
Use elimination? Okay, I'd love.
You add them to it.
Yeah.
Oh, okay.
Yeah, that's great. That's great. So that clearly worked as well. You just stacked these on top of each other and it worked out. Beautiful. I'm going to take a look at your paper as well. Excellent job. Any other comments or questions? Good. So, good job so far. So we've wrapped up the previous lesson. We're back to today's. We're going to wrap up chapter 10 by exploring the concepts of circles and how they relate to the coordinate plane. We're going to be writing equations of circles, and we're going to be graphing circles. That's why I asked you to make sure you're using graph paper today. It's also why you have a compass at your desk. We're going to be using the compass quite a bit today. So let's start with our goals. Our goals are to be able to write equations of circles and graph circles in the coordinate plane and use these ideas to solve problems. So, first, we need to build the idea of the circle in the coordinate plane. So, do not copy, just please pay attention, and you're going to see what you need to write down in a moment. In this diagram, I have a circle whose center is just somewhere in the coordinate plane. I've labeled it HK. So the coordinates of the center are H, K. A point on the circle is labeled here XY, and the radius is labeled R. Now, underneath you see we have the distance formula, which you're intimately familiar with. We don't know what R is, but we could find R because R represents the distance from this point to this point. So we can use the distance formula to find it. So work along with me, and what we're going to do is we're going to use the distance formula and use the labels in this diagram to find something. So let's go ahead. First of all, the distance that we're finding is actually R. So we can replace the D with an R. Then we need to take the square root of some calculations. Let's go ahead and label what we have here with the x1, y1, x2, y2. So we're going to call this x1, y1, x2, y2. So now let's plug those values into the distance formula. So, we've got the difference of the x's. x2 minus x1, which in this case is h. And we're going to add to it the differences of the y squared. y2 is just y minus y1, which is k. We almost have an equation for a circle that we can use over and over again, a model equation. Just to make it look a little bit nicer, we're going to get rid of the square root. You already know how to do that. If we square a square root, it disappears, but then we have to do that to both sides. So let's go ahead and do that, and we finish with r squared equals x minus h squared plus y minus k squared. And that is how you derive the formula for the equation of a circle from the distance formula. That's going to be important for us moving forward. So I'm sorry, I said you didn't have to copy the diagram. I guess I may have said don't copy, but yeah, there's stuff you're going to need to know. So yeah, I'm sorry. You're going to have to pick up your pencil and get to work. I apologize. You should have been working at some point while we were doing that. Because unfortunately, for some of you, you hear the words, put your pencil down, and you go off into your own little spacey world. Yes? So, we set up a circle with particular labels, and then we can derive the formula for the equation of a circle from the distance formula. So there is a tight connection between the distance formula and the equation of a circle. Any questions about that? We can take it a step further. I have another circle, and it's on another coordinate grid. This time I have a grid that's labeled. And the center of this circle is at the origin, right there. So one thing I want you to be aware of is that this is an ordered pair for that point. This is the x value, and this is the y value. Well, what if I put in this line right here? What is that distance right there? Valerie, what's that distance? That distance is 2. Do you see a 2 anywhere else? Say it again. Yeah, that's the value of x right there, so we could call that x. And what if I put this distance right there? What is that distance? What's that distance, Stephanie?
3.464.
Very good. So that's 3.464, and so that distance is also labeled, it's called y. And what if I put in that line right there? What is that distance? Eric?
Radius.
That's radius. That's the radius of the circle. What just popped up inside the circle? John?
Right triangle.
Very good. That is a right triangle. What concept do we use frequently with right triangles? What concept do we use frequently with right triangles? We've used it all year. Stephen? Pythagorean theorem. So if I take this right triangle, x squared plus y squared will equal r squared. And where's the origin? At 0, 0, right? Watch this. If I take this equation of a circle and put in the center, it's x minus 0 squared plus y minus 0 squared equals radius squared. Huh, look at that. Now what happens when we square 0? Excuse me. Square 0, we get nothing. We square 0, we get nothing. So if we rewrote this, it would become x squared plus y squared equals r squared, which is the same thing we just got here from the Pythagorean theorem. Does anyone know why this happens? Why we got the Pythagorean theorem and we got the equation for the center of a circle? All the same?
Just finding the center of the circle with one circle.
Maybe. Yeah, you might be right. Well, we started with what formula did we start with? What formula did we start with, Alexandra? And what formula did we just use here? Matthew? Good. What's the connection? You're using both what? Good. You're using both to find measurements. But what's the connection between all of them? Clearly you don't see it. That's fine. You're going to kick yourself. Extol? We do, but the question is why? We use the distance formula and then the Pythagorean theorem and we end up with the same thing? How is that possible? Sharif?
Because the distance formula is just like the Pythagorean theorem, except everything's square rooted.
So say it even better. You said it's just like.
So basically, in the distance formula, both sides are like, you take the square root of both sides from the Pythagorean theorem, and that's the distance formula.
Yeah, the Pythagorean theorem is the distance formula. The distance formula is the Pythagorean theorem. You guys have actually seen that before. Long time ago. Pythagorean theorem and distance formula are the same thing. The distance formula is derived from the Pythagorean theorem. So this is all interconnected, and it's all interconnected with the concept of the circle. This is something you need to understand moving forward. The distance formula and the Pythagorean theorem are the same thing. Okay, so now we're going to start using all this. Does anyone have any comments or questions? Okay, so example 1. Let's start writing equations for circles. So, the equation of a circle is going to be r squared equals x minus h squared plus y minus k squared. HK is the center of a circle, and we're told that the center is right here. This is H, and this is K, and I'm sorry that I used the capital letter K. I shouldn't have done that, and I didn't realize it at the time. So don't worry about that other capital K. That's the center of the circle. So all we have to do is take this piece of information, and plug it in the appropriate place. So let's go ahead and do that. So we've got r squared equals x. Now we do minus, so you got to be aware of that, minus h, so minus 1 squared, plus y minus k, but k is negative 8, so minus a negative means we flip it. And so that will become plus 8 squared. And so we almost have the equation of the circle that's explained to us in the text. But we have one issue. This right here is missing. To write an equation of a circle, we don't want r squared. We want an actual number. So we need to know the radius. Or at least we need to know radius squared. Anyone have any suggestions? John?
Well, since point D is on the floor of the circle, I imagine that if you drew a line from the center into that point, you would make a radius. So then I put 6 and 4 extra.
Okay, so you have a couple of choices. We're going to do it one way, and that is another way. We could take 6 and 4, plug them in here and here, and then crank this out to get r squared. We're going to take a hair longer approach for a reason. And then after we do this, you can choose whichever method you want. But what John said was pretty great, is that if we connect j to k, we get a radius. And a radius is a distance. So if we use the distance formula, d equals the square root of the difference of the x's squared plus the difference of the y squared, we will get that distance. But that distance is actually the radius. So if we replace everything with the appropriate pieces of information, if we now say that this is x1, y1, and now say that this is x2, y2, we can now find the distance, which is almost the same thing that John had suggested. There is a reason why we're doing this, so just follow along with me. So, x2 is 1 minus x1 is 6 squared. y2 is negative 8. y1 is 4. Square it. Now crank that out and get what r is. So you go ahead and get r. You already got it, Steve? Go ahead, Stephen. What does it come out to?
R is equal to 16.
Yeah, R equals 13. So now we can take that value and plug it in right there. And we will get the equation of the circle. 13 squared is 169 equals x minus 1 squared plus y plus 8 squared. And that is the equation of the circle outlined in the text. So this side trip here was to just find this piece of information. So that was a slightly longer approach than what John suggested, which was to plug in the 6 here, plug in the 4 here, crank it out, and you would have gotten the 169. So that actually was a little bit faster, but here's my concern. I am concerned that my students will actually stop and not finish the question or finish finding what you're supposed to find. I'm concerned that my students won't realize that after you put in the 6 and the 4, then you're going to have to rewrite it again without the 6 and the 4. If you can handle that, by all means, go ahead and do it. If you're like me and you tend to get lost a little bit on, when there's a lot of work involved, then I would stick to finding this separately and then plugging it back in. Either way, you're going to get the same result. Any questions about that? Good, so let's take a look at another one. Write the standard form of the equation for circle J with center J at 2, 2 and radius of 4. You should be done. I put this here just to make sure that my advanced students, that's you, my advanced students don't overthink things. One risk that smart people have is overthinking something that's simple. And so I wanted to make sure you didn't overthink it. So all the information is given to us. There's nothing to find. All you have to do is put the information in the right place. Radius is 4, square it, you get 16, equals x minus 2 squared plus y minus 2 squared. And that is the equation of the circle described in the text. Any questions about that? Any concerns about writing the equation of a circle? Good, we're doing quite well. Checkpoint number 1. You got 2 equations I'd like you to write for me. 2 equations, you got 2 minutes. If you're concerned, you're lost, you have a question, please let me know. let's see how we did. Part A, I've got students 19 and 3. Student number 19. What'd you put? Part A? Oh, okay. Student number 3?
I'm confused with the radius part, but I got 16 equals x minus 2 squared plus y plus 1 squared.
Okay. So the correct equation is 16 equals x minus 2 squared plus y plus 1 squared. Part B was ridiculously easy, so just reveal that. If one of the coordinates of the center of the circle is a 0, then you just eliminate that part from the formula. If you wrote x plus 0 squared, that's fine, that's the same thing. So what happened? We struggled with the distance formula? Where did we go wrong? Come on.
If we do it John's way, like the plugging the corner right there, after we get like that side of the equation, we don't square the answer.
That's right. You get the radius squared. You don't just get the radius. Okay, so you got to be aware of that. That was another thing that I was concerned about. Did you do it right or did you make a mistake?
At first I did 16 and then Sebastian told me 16 squares.
Okay, so let me go back because this was another concern of mine. John's method was to plug in a 6 here and plug in the 4 here. But look what's on this side. It says r squared equals all of that. So you will get, in this case, 169, which means you just take that number and you plug it in right here. You don't square it and you don't take the square root of it. If you do my method, which is the distance, you get the radius. Then you have to square the radius to put it in there. Okay? So thank you for bringing that up. That's what you meant when you said you were confused about the radius? Is it clearer now?
Yeah.
Okay, good. Any other comments or questions? Okay, so now let's go in reverse. Let's start with an equation and let's graph a circle. So what I'd like you to do is draw a coordinate grid, at least 8 in each direction. You're probably going to have to go even further than that. Go about 10 in each direction. Or at least just leave yourself some space. So you could start out a little bit smaller, and if you need to expand it, then you can. So, you have a grid set up. Everything you need to graph a circle from an equation is contained within the equation, and all you need in addition is a compass, which I provided for you. It's sitting on your desk. So, the center of the circle is located at the opposite of that value, comma, the opposite of that value. That's our starting point, the center of the circle. So we're going to go ahead and draw that. So the center will be at positive 3, negative 4. Positive 3, 1, 2, 3, negative 4, 1, 2, 3, 4. Put the center of the circle. Now all we need is the radius of the circle and a compass. The radius of the circle is contained on the other side of the equation right here. It's the square root of that number. So the radius is 5. So now we're going to use the straight lines on the grid, and we're going to go 5 units over. 1, 2, 3, 4, 5 from the center of the circle. Now, your compass is different than mine, so you're going to have to translate what I'm doing and demonstrating to your tool. So, my compass is the more traditional, and here's how it works. I'm going to put the point of mine on the center of the circle. You're going to put the crosshairs of yours on the center of the circle. I am going to push the pencil part of mine so that the point is at the center of my other point here, so that I have matched the distance between the 2 points. You have to move the red piece on yours. I see you already got it. And then you draw the circle. And you will know if you did a good job, because if you check the radius at north, west, and south, you should see your circle cross perfectly at 5 units away from the center. So for example, 5 units away going north is right here, 5 units away going west is over here, and 5 units away going south is right here. So I was able to actually draw, for the first time, a virtually perfect circle. Does anyone have any questions about that? Any concerns? Good, we're doing quite well. No concerns? So let's go ahead and use the same grid for part B. Part B, x squared plus y squared equals 36. When you see that there's no value with the x and no value with the y, what does that tell you? There's no value with the x and there's no value with the y. Diana? Very good. The center is going to be at the origin. It's at 0, 0 right there. So we already know our starting point took no effort. And then we just need another point that's the radius distance away. The radius will be the square root of this number. So we know that the radius is 6. So now go 6 units. 1, 2, 3, 4, 5, 6. Put a point and use your compass to draw the circle. And once again, check and make sure that the radius held true going north, west, south, or it doesn't really matter which direction you started at. It should end up to be the same. Does anyone have any questions or concerns on how we can draw a circle from the equation of a circle? Nothing at all? Okay, well, I'm hesitant to tell you to do the checkpoint on the same grid, so let's do a new grid. I think it's just going to become too much. So I'd like you to quickly draw a new grid, and I would like you to graph this circle. To me, it's like a 2-minute process. So we'll start with 2 minutes. If I need to expand that, if I notice that everybody's still working, I will expand it. lend itself to sharing out. So here is graph of the circle. My graph got cut off a little bit when I tried to set it up for this, so I apologize if the bottom of my circle's cut off. But the center is at 3, -2, and the radius is 4. So that's what you should have gotten. Anyone have any concerns or questions? Anything at all? Give me a thumbs up if you got it. Good, nice. Checkpoint number 3, team challenge. So, read it to yourselves, work with your team, and answer the question. And the question gets a little lost, so I'm going to underline it for you. Oop, not like that. You guys got it?
Yeah, nothing's
You guys got it?
See, because
All right. So, let's see what we got. Give me a thumbs up if you and your team found the epicenter of the earthquake. Got Team E, Team A, Team C. You guys, did you find it? No? Okay, put your thumbs down. Okay, X-Dole, where is it? Where do you think it is, Eric? Your whole team thought the same thing? Okay. Matthew, where did your team think it was? Okay. Stephen, your team didn't find it?
no.
I'm sorry? Yeah, okay. So it is at 5,2. So I gave you no guidance. This was quite intentional. But what you were trying to find was the point of intersection between the 3 circles formed with these starting centers and the distance away from them. So here's what your diagram might have looked like. When I reproduced it, unfortunately, it got a bit pixelated, so it's a little bit hard to see, a little fuzzy, but you can get the idea that the centers of these locations, here, here, and here, and then you're told the distance is 7 miles away. So if you draw 7 away from point A, and then use a radius of 4 for point B and a radius of 5 for point C, then draw 3 circles. The point where all 3 of them intersect is called the epicenter.
Extensions. 1 centimeter.
Hold on. So that was the goal. I did not give you a lot of guidance on that. I didn't even tell you what you were really looking for. I wanted to see what you guys would figure out. And many of you did, and that was great. So, extension. Why are 3 circles needed and not 2? Sebastian?
Because 2 circles intersect at 2 points.
2 circles intersect at 2 points. Let's see. So if I got circles A and B, it intersects here and here. If I got A and C, it intersects here and here. And then B and C intersect here and here. So yeah, 2 circles intersects at 2 points. You don't have a point of intersection. You can't find the right point. It is not until you get 3 locations, 3 circles, and find the point where all 3 of them intersect that you find the epicenter. Kamoy, your comment or question? Go ahead.
Can you look at my picture because I did all the measurements and circles right there. I didn't get 5 points.
Okay, I'll come take a look. Any other comments, questions?
If like the circles are like separated, would it still be like? No.
That's a good question. I don't have enough background in the science behind it to know what would happen, but you're saying, what if point A was way over here? And, well, wait, no, because these are, 1 second. What's happening is at these locations, there's a machine taking a measurement. So there's a machine here, there's a machine here, and there's a machine here. These 3 machines are taking a measurement that tells them how far away the center of the earthquake was, and by using all 3 of them, we can find it. If this point was way over here, it wouldn't have felt the earthquake. If it did, it's possible that it felt a different earthquake, and then it would have to figure out where that earthquake came from. And that's why we use different locations to try and triangulate where the epicenter is. It's a really good question. All right, your homework is page 692. You're going to do numbers 12 through 28, 31, and 32. You are going to need a compass. I have compasses to loan to you if you need. Number 35 is for my advanced students. It is optional. It's extra credit. The answer is not on the answer sheet, but if you think you've got the right answer, please bring it to me during care, and I will tell you whether or not you got it right, and I will award you extra credit accordingly.